Hi there, welcome back to Tiewire Building Solutions. Today on the channel we're out on site and we're round the back of a customer's property, and we're going to be putting 3 of the Mark 3 tie wires onto this canopy. This canopy you see behind me, anthracite grey, will be double glazed on this elevation, and we'll have a composite style solid roof on the rear. Different pitches, this side is different to the other side, the ridge isn't in the middle. It's at 10 degrees, so it's relatively flat but adequate for getting the rainwater off. And we're going to try and equally space out these 3 wires, fixed to timber on the rear rafters and onto a patent glazing style rafter on this front elevation. The length is just over 3 meters on the wires. So yeah, we'll crack on and get started. So when the wires arrive, you'll get them in a small pizza size style box. They'll be coiled up in this manner. There'll be the wire assembly itself with a fork fixing on the one end. There'll be a tensioner assembly at the other end, just terminating there with another fork terminal. Very simple. You'll see that as we open it out as to what they look like. Also, you'll have a pair of brackets with each wire. The brackets are symmetrical in design on their width, slightly unsymmetrical on their depth. There'll be a pair of those per wire, and then depending on the nature of how the brackets will be fixed to the structure, we've got a fixing kit here, and in this instance we have got some 80mm long Torx head screws. There'll be 4 per bracket, and we'll be firing those into the rafter sections. So coming in closer to the roof itself, just take you and have a little look inside. As you can see, it's basically open on 3 of the elevations. The eaves beam is supported on these fantastic looking ornate columns. It looks like it's attached back to the property as well. Got some good wall fixings in there. These are the kind of bolstered composite rafters which will be there to accept the glass. Not too sure whether it's double or single glazed. But at the rear we've got a more traditional style of construction. We've got a T&G boarded rafter sections. Where the wires are going, the customer has used a wider section timber when compared to the ones which are intermediate. So we know exactly where these wires have got to go, and from a fixing point of view into these patent glazing style rafters, the customer has thought in advance and has slid up the hollow section of this bolster, a shaped piece of timber, probably extending up a couple of foot into the rafter, give us something nice and chunky to fire these screws into. So this is the plan: 3 wires roughly equally spaced, pulling or helping restrain the 2 elevations of this roof together, just to stop any spread or possibility of spread. Keep these columns vertical and not apply too much load onto this boundary wall. So let's crack on. The initial part of the installation I will now show you. We have cut a piece of profile to the dimension which the customer gave us. The customer requested a dimension of, looking at the label, 3/150. So the profile was cut to 3/150. We clamped it in the customer's required position at the bottom, so the bracket is very close to the eaves beam there, which is good. Profile cut to 3150, spirit level on the profile, keeping it horizontal, and then clamped off in position on that timber rafter. We then positioned one of the brackets, bottom of the bracket, in relation to the bottom of that profile, and as you can see, looking at the underside of this timber rafter, hopefully it picks up on the camera, you can see 4 positions marked with the marker pen to show us where the 4 fixings are going to go through for the brackets. So that's where we are so far. The brackets are now fixed up there, as you've seen on the footage. 4 fat screws holding them into this timber section and reinforced section. Now uncoiled the wire. The wire, as you see, is unsymmetrical in its design. On the one end we've got a swaged on fork that's pressed on there using a 10-ton swaging machine, which literally squashes the metal onto the end of the 6mm stainless steel cable. This is good for a brake load of about 3.1 tons, safe working load of about a ton and a half per assembly. So there's more than adequate capacity in the loading of this assembly. So we'll get the wire up on there and get this one tensioned up. I'm just adjusting this to mid tension, so we'll have the similar amount of thread on the left hand side as on the right hand side. The cable has got a right hand threaded M12 swage connector on there, and the fork end coming into the tensioner body is a left hand thread. So this M12 tensioner, left and right hand threads, will just simply be rotated in the typical turnbuckle style to draw the cable in onto the one end and to draw it itself onto the fork on the other end. So on the end of the fork we have a pin with a split ring on the side. Take the ring off, pull the pin out, and then we can basically anchor that onto the eye of the bracket that we've just installed. Pin back through the hole. split pin back on. Both sides connected up. Rotate the tensioner. Get it as tight as you can with your hand, making sure not to let the wire twist as you're rotating the tensioner body. As you can see, we've still got plenty of adjustment left on the threads there. That's quite tight as it is, but for continuing to tighten it, to bring more tension into the assembly, what we can do is we can apply a spanner, 10mm spanner, onto the spanner flats on this swage stud on the end. Get ourselves a little Allen key or a thin screwdriver through the eye in the tensioner and just carefully nip it up. We can keep checking the posts for vertical plumb, but yeah, once the roof is fully loaded up on this, you'll be able to swing off this wire basically. So yeah, let's go for some final tension on this assembly. Yeah, final adjustment on the tension, 10mm spanner on the spanner flat, and rotation of the tensioner. I can hear the thing creaking now, so I know it's pulling on the rafters, it's pushing that ridge up into the air. We don't want to overdo it to deflect the eaves beam or to pull the columns out of vertical plumb. So there's no lockout in that, nothing's got bound up. It's pulling on the eyes of the bracket exactly where it's supposed to, and I think as the other two wires, as we move forward down the tunnel of the roof, we'll just keep checking the straightness of the eaves beam and the verticality of the supporting columns. But apart from that, quite a quick and simple, easy job to do. So let's crack on with the other two.